Does this lovely countdown clock look familiar to you? And has yours also mysteriously stopped working? Well, if you answered yes to both questions simultaneously, then you're watching the right video. I'm about to go through the basic process of troubleshooting and repairing this wonderful LED timepiece. No guarantees, though. So originally this had a piece of cardboard over here, and it had advertising and all this other crap, and then it just died. So I took the cardboard and stuff off, and don't mind that. And there's a circuit board right here. That's what we're interested in. Alright, so here's a close-up of the circuit board. It looks a little more complicated than it is, so I'll just go through the basics of what's on here. There was a piece of cardboard that went over this, and I just kind of ripped that out without regard for its poor cardboardy life. It also had some screws, and I ripped those out because I'm just a jerk. This is a power jack. This is where it takes its 7.5 volts from a wall wart. I believe it's 7.5 volts. I hope so. This is the backup battery, so once you've entered your dates and countdowns and all of that stuff, you don't lose it by unplugging it and moving it across the room. It's just a standard 3-volt coin cell like you'd find in a motherboard. I believe this is the timer circuitry, rather. There's a crystal on here, and it comes off, so I would assume that's what that is. Resistors for each of the LEDs, LED drivers, and these are the ribbon cables that obviously go to each of the giant LED displays. What I'm really interested in, though, is right here. This is the voltage regulator. This takes the 7.5 volts and converts it down to 5 volts, and it's an LM78L05, I believe, voltage regulator. And I already metered it. I used my multimeter and I checked all the outputs on the rest of the board, and this was the only thing that wasn't doing what it was supposed to be doing. I don't have any of this package type, so I'm just going to replace it with a standard LM7805, and I'm going to show you how to do that. I have liberated the circuit board from its plastic prison. As you can see, here's the voltage regulator. This is what we're going to take out and replace with one of these. This is just a standard LM7805 linear voltage regulator. It's not the most efficient thing in the world, but it'll do exactly what we need to do here. Now, this won't drop right into the board because, if you turn the board over, you can see these are the traces, or not the traces, these are the through holes for it, these three make up the triangle, and this obviously does not just, go there. So I could fiddle about with trying to bend these and make them fit and all that crap, but I found this, which is just a standard jumper cable. It's got 3 wires on it that I already cut and tinned, and the voltage regulator fits right in. So now you should be going to your data sheets and looking up the pinout. Thankfully, the pinout for both of these is exactly the same. Now I'm going to forget, but I'll tell you anyway, even if it's false. When you're looking at it this way, top is output, center is ground, bottom is input. You got that? Good, because I'm not going to explain it again. So first I need to desolder the old chip. Do yourself a favor, when you're removing any type of circuit thing from a board, do this right here. Take a pair of pliers, put a rubber band around it. This isn't the prettiest thing in the world, and I'm sure I'm going to get yelled at for this by someone, but it works. So basically you clamp down on the component like so, and then you use gravity to help you desolder it. In this case, I don't really need to heat up all of the pads at once separately, because as you can see, they're so close together. I can just kind of put the iron on it like this. You'll see in a second. And I can heat up all 3 pads at once and just release it. So I'm going to do that. Hopefully this works. And once you've heated up all the pads, just kind of wiggle it back and forth a little bit. And there it goes. It pops right out. Now we don't have any more voltage regulator, because this thing's bad and we don't want it anymore. Goodbye. Now, the new one's going to go in. You could just kind of solder this in, like, on this side, and it would look really ugly, and then it wouldn't fit in the plastic anymore, but that's not how I roll. So make sure you get rid of any excess solder in there. Again, I've done that already for at least 2 of the holes you can see there. And solder it back in. So I will do that now. And on the board side, oh, there's my pen. You have, that's the center pin. That's ground, if you hadn't gathered that. This is input, and that's output. This is not rocket science. Make sure you tin your wires ahead of time and make sure they go all the way through the circuit board, or I'll come to your house and cut you. Once you've got your wires soldered in from the top, turn the board over and smack it with a hammer for good measure. Or if you want it to actually work, just hit these pads again, put a little bit more solder on there. Just make sure nothing bridges, obviously, but make sure there's enough solder on there. Alright, so I've returned the circuit board to its plastic prison, and I have a variable voltage power supply over in the corner, and I'm going to switch it up to 7.5 volts and see if my little hack job worked. Huzzah! Now, you can see in the corner the power supply over there with the other LEDs blinking. 7.5 volts, it's drawing about 1/4 of an amp, and I can actually turn this up and make the LEDs brighter, but I'm not sure how far I can go with that before I start burning things out. But you're not going to find a wall wart that's exactly 7.5 volts, because they tend to drift quite a bit, but again, that's another rant. So I hope you found this useful, and if you didn't, then go fly a kite.